Okay, today is 4.7 and we'll be talking about direct variation. In 4.7, direct variation, we're going to be using this equation. Make this your friend, write it on your fridge, say it in your sleep, y equals kx, where k is the constant of variation. Okay, so normally in a direct variation, we'll have y equals, and then we put a number here, and then we put x, like y equals 3x, or y equals 5x. Or y equals 1/2 x. We just put a number in for k, which is the constant of variation. Okay? So, knowing that equation, we can do a problem. This is off of your homework, number 1. And they give you some data, and they say, determine if y varies directly with x. So, in the equation, y equals kx, the way that I would say this is y varies directly with x. Now, there is y varies inversely with x, but that's not this lesson. We won't be doing that today. So I would say y varies directly with x. So we're going to see if this data fits into this equation. And if it does, we will say, yes, y varies directly with x. Okay, so can I take x and multiply it by a number to get y? Now these aren't nice, pretty whole numbers, so we can basically divide both sides by x so that x cancels and k equals y over x. So we're going to see if I can take y and divide it by x and get a constant number every single time. Okay, so I'm going to take y, 29.4, and divide it by x, and in my calculator I get 4.9. Now, if I can take y and divide by x and always get 4.9, then I know I have a direct variation. So I'm going to take 34.3 divide by 7, and I get, 4.9. So I have a pretty high opinion that it's probably going to be a direct variation, but I'm going to try another one. How about 39.2 divided by 8, and I get 4.9. So it's looking to me like this is, that's a 4. This is a direct variation. Let's try one more. 44.1 divided by 9, and 44.1 divided by 9, I think I multiplied, and I get 4.9. Okay, so yes, every time I take y and divide it by x, I keep getting the same number. It's constantly 4.9. This is the constant variation. So y varies directly with x, and the constant of variation is 4.9. Okay, moving on to number 2. Using the data in the table, determine if y varies directly with x. So we're going to do the exact same thing. We're going to decide if k will always equal the same thing when I divide y by x. And if so, then we say yes it is. So let's take negative 23.4 divided by 6, and I get negative 3.9. So let's do this one. Negative 27.3 divided by 7, and I get negative 3.9. Looking hopeful. Negative 31.2 divided by 8, negative 3.9. You know, I'm going to skip down here just to be sure. Negative 33 divided by 11. Hey, I get negative 3. That's not negative 3.9. So, since I don't always get the same thing, I mean, I did for a lot of them, but because it's not negative 3.9 all the way down, I always say y does not vary directly with x. On your homework, you can guess and get it wrong, but on the test, you better check every single one of them in case at the bottom they don't have it work out. All right, number 3, determine if the graph shows direct variation. If it does, state the constant of variation. So I'm going to come back up to here what I showed you originally. Direct variation is y equals kx. This to me looks like the equation y equals mx plus b, where m or k is the slope, x is there, y is there, and b must be 0 because it's not here. It's like saying plus 0. So the constant of variation is the slope of the line. So when I come over here and I say, well, this will be a direct variation if if it's a line. Whether this is an M or a K, it's the equation of the line. So anytime you have a line, it is definitely direct variations. I know that for sure. To find the constant of variation, that's this, then we need to find M. You can find M by either finding any 2 points on here and getting to another one. For example, let's say I'm trying to get from this point to this point. Remember, this slope is rise over run, so you can decide how far did I have to rise and how far did I have to run to get from one point to the other. It looks like I went up 2 and right 2. Up 2 and right 2 is 2 over 2, which reduces to 1, so the constant of variation is 1. You can also use that formula, y2 minus y1, x2 minus x1, because I have the point. In this case, I highlighted the point negative 2 comma 0 and 0 comma 2, and you could plug it in here, but that's more work. So if they have the graph, just do a rise and a run. So the slope of the line is the constant of variation. Okay? Determine if the graph shows direct variation. Indeed, it does, because it's a line. Every line is constant, is direct variation. No, so in this case, I would have to see, what's the rise and the run? So, oh, it's hard for me to see these grids. There's a point, and I want to get from there to here. So it looks like I would go up 1, up 2, and then left 1, 2, 3, 4, left 4. If I reduce that, the slope is negative 1/2, which means the constant of variation is negative 1/2. Okay? All right. Write an equation to describe the variation. So remember, variation that varies directly will look like this, y equals kx. So if I'm going to say this, I would say y varies directly as x. So if it says s varies directly as g, I would just plug in the s there, k is always k, and plug the g in here. There you go, s varies directly as g. If f varies jointly with m and s, that's the same thing, it just means I have more letters here. So instead of saying y varies directly as x, I would say f varies jointly, make sure you have your k, as m and s. Just put m and s both there. They're joined at the hip, jointly. Okay, so that's how you can rewrite equations with different letters. No big deal. If y varies directly as x, find the constant of variation in the direct variation equation. Okay, so they're going to give you a y and an x. So I'm going to take my y varies directly as x equation, and I'm going to plug this in for y, and I'm going to plug that in for x, and then I'm going to see what k is. So plug in y. 0.2 equals k times x is 1.5. And then I can solve for k by dividing by 1.5. What I do to one side, I do to the other. So k equals 0.2 divided by 1.5, which is 0.1333. That repeats. Okay. The 1 doesn't repeat, the 3 repeats. Oh, it says round to 1 decimal place. So 0.1. If I round to 1 decimal place. And then write the direct variation equation. So we're going to write this equation, but instead of k, I'm going to plug in k. So it would be y equals my newfound k, x. So this is the constant of variation. I plug it in for k. This is the equation. Okay? Suppose j varies jointly with g and v. So the equation would be j, that's a j, varies jointly with g and v. So first I come up with the equation. What is the constant of variation? So I'm trying to find K, but I'm going to plug these numbers in for J, G, and V to try and solve it. So J is 3 equals K times 6 times 5. Well, that's just 30. So what I have is 30K equals 3. So I can divide both sides by 30 so that I have K by itself, and now I know K is 1/10. So what is the constant of variation? Type in integer or a fraction. I can put 1/10 in there. Then it said, oh, they don't ask for anything else. They just want the constant of variation. They don't need the equation, so you are done. Okay, number 9, and I think oh, it only goes to 9. Number 9 says the pressure exerted by a certain liquid at a given point varies directly, that tells you which equation to use, as the depth of the point beneath the surface of the liquid. So blah, 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 we just need to come up with letters, okay? So we can write this as the pressure exerted by a certain liquid at a given point, I'm just going to use P for pressure, varies directly, so put your constant in there, as the depth of the point beneath the surface of the liquid, so I'll use D for depth. The pressure at 90 feet is 540 pounds. What is the pressure at? Before we can find the pressure, we need the constant. So let's plug in the two numbers they gave us. If the pressure is 90, plug that in. I don't know what K is. And the depth is 540. So I'm going to divide by 540 to find K. So this cancels, and I will have K equals, what is 90 divided by 540? You can come up with a decimal or a fraction, it really doesn't matter. And the 6 repeats. I know in your TI-30s you can have a fraction, but I don't have a TI-30 right now. But I guess it would just be 1/6. Trying to do that in my head. All right, so we know what K is, but it's not asking for the constant of variation. It wants to know the pressure at 30 feet. When they give you this third random number, that means plug it into the equation. So the equation was P equals KD, and I know what K is. K is just 1/6, okay? And this number right here, is this a pressure? Or is it a depth? Hey, did I do that backwards? The pressure at 90 feet. Oh, I did it backwards. This is the pressure. Shiznit. Okay. The pressure is 540 and the depth is 90. So when I divide by 90, I get 6. Okay, so K is 6. So I'm going to plug in 6 for K. And then this, is it a depth or a pressure? Well, that's a depth, so I'll go ahead and plug that in for depth. That way I can find the pressure. What is 6 times 30? 180. So it says, what's the pressure? When this is 30, what's the pressure? Well, it's 180. Okay, so that is this lesson. Though, as I was giving the lesson, I realized, I want to come back to these. Anytime you have a line, it is direct variation, but only if it goes through the origin. It has to go through the origin because I need to have a 0 here. The y-intercept has to be 0. So if it touches the origin, then yes, it's direct variation, and the slope would be here. But if it doesn't go through the origin, then it's not a direct variation. Because in this case, I would have a b. B is actually 2, right? So I can't have a 2. I apologize. I misspoke. Not all lines are direct variations. Only lines that go through the origin are direct variations. So this is not a direct variation. this is not a direct variation. But I apologize if I misspoke. All right, folks, that is 4.7.